Welcome to Study Guide Forum. Today we'll be looking at specific heat capacity. We have a question on the board say that a piece of copper of mass 130 gram is heated in an enclosure to temperature of 132 degrees Celsius. It is then taken out of the enclosure and held in air for half a minute and dropped carefully into a copper calorimeter of mass 100 grams containing 200 grams of water at 20 degrees Celsius. The temperature of the water rises to 25 degrees Celsius. Calculate the rate at which the heat is being lost from the piece of copper when it's held in air. And specific heat capacity of water is 4200 joule per kilogram per Celsius. And specific heat capacity of copper is 400 joule per Kelvin per kilogram per Celsius. Alright, here now, the first thing we do, you notice that there's a kind of heat. Heat is the copper mass is losing a heat while the calorimeter and the water in it is getting a heat. So let's see the quantity of heat the copper mass is losing. Heat lost by copper mass is equal to mass of copper, specific heat of copper, and temperature. That would be mass of copper we have times specific heat of copper times temperature, that's temperature change. We have the initial temperature there is 129 degree, and then the final temperature is 25 degree. So here we'll convert. If we divide this by, this is in gram, if we divide it by 1000 converting to kilogram, we have 0.13 kilogram times, and then we'll have this subtracting each other, we'll have 104. So when you multiply it, if you multiply this, we'll have the heat lost by this to be 5408 joules. That's the quantity of heat lost by the copper mass. Now, the heat gained by the calorimeter and the water inside it. That will give us the heat gained by the calorimeter and water will be equal to mass of the calorimeter multiplied by specific heat of the calorimeter and temperature. This plus mass of the water, specific heat capacity of the water, and then times temperature. In that case, we know we have the mass of the calorimeter is 100 grams. Converting it to kilogram, we have 0.1, and then the other one, the specific capacity of the copper calorimeter is 400. So the heat gain, since the initial temperature is 20, then the final temperature is 25, then the heat gain is what? We will say it's 5, and then times 400 times 0.1 plus plus this other one, which is 200 grams, converting to kilogram, we have 0.2 kilogram times, and then times change in temperature, which will give us percent 5. So the total heat for each of them, will have, this is 200 grams plus 4 to joule, 200 joule plus 4 joule, 4200 joules. That will give us 4 joules, 400 joules. So now so the heat loss from the heat loss in air, the heat loss in air will be equal to 5408 joule minus 4400 joule. That will give us 1008 joules. Now the question now said that we should calculate the rate of heat loss in half a minute. In half a minute is something as 30 seconds. Half a minute, 30 seconds, that is time. Let's say time is equal to 30 seconds, and then the heat loss in air, that is quantity of heat is equal to quantity of heat is equal to 1800 joules. Then dividing it, the rate of change, that will give us 30 seconds, 1008 joules. 1008 joules divided by 30 seconds, we will get 3.6 joule seconds. Alright, thank you so much. Remember to comment, subscribe if you have not, and then you can like. Thank you.